The frustration you feel about being stuck in tutorial hell while seniors seem to skip coding entirely has a name, and it isn't because they are lazy or hoarding secrets. In an era where AI can write syntax instantly, writing more lines of code is no longer a metric for seniority. It is actually a liability. The shift from mid-level engineer to staff level requires you to stop asking how to write a function and start designing trade-offs that survive hardware limits and data constraints before a single line exists. This video explains the specific engineering judgment required to anticipate failure modes rather than just fixing bugs, showing you why your next promotion depends on managing risk instead of learning new frameworks. The core reason for this identity crisis lies in how senior engineers perceive their value when generative AI enters the workspace. Research from LSE and Harvard reveals a stark divide. Junior developers view these tools as aids to learn syntax, while seniors see them as threats to their unique standing because they know that if code generation is automated, their leverage must shift elsewhere. Seniors engage in what researchers call identity protection by focusing on tacit knowledge, the deep, unwritten understanding required for system design that AI cannot replicate yet. They understand that the real work happens before implementation begins, where decisions about hardware memory and latency are made to prevent catastrophic failure later. This transition is not just about working harder. It is a fundamental change in how engineers view their environment. A study published at ACM DIS 24 involving 15 semi-structured interviews highlights this shift perfectly. The research found that junior thinking often remains trapped in single-user scenarios, focusing on metrics like gesture recognition accuracy for one person interacting with an interface. In contrast, senior designers expand the design space to manage multi-user dynamics and feedback loops under collective pressure. They anticipate where individual code will break when thousands of users hit an endpoint simultaneously, ensuring the system holds up rather than just working in a vacuum. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider how this plays out in real-world constraints that tutorials rarely cover. A mid-level engineer might build a feature that works perfectly on their local machine with abundant RAM and CPU power. They celebrate the speed of implementation, but fail to account for GPU memory limits when scaling to 10,000 concurrent users or data bottlenecks during high-traffic windows. The senior approach flips this script by asking, "What breaks if we scale this?" This mindset shift is critical because it moves intrinsic motivation from the joy of writing code to navigating complex extrinsic structures and technical training gaps that block junior developers in professional practice. Modern engineering frameworks are already codifying this behavior into automated workflows for AI agents. These systems enforce a strict pipeline where no code is written until a design spec exploring trade-offs receives formal approval. This mimics the staff engineer level of thinking by utilizing 4 distinct roles: architect, tech lead, manager, and compliance. Before any logic is generated, these teams trace root causes 5 levels deep to ensure that hardware constraints and data flows are fully understood. It forces engineers to define API design and interface limits before touching a keyboard, ensuring that the final product can survive real-world chaos rather than just passing unit tests in isolation. This spec before code discipline is becoming the new standard for production-grade reliability. A 6-phase lifecycle now dominates senior workflows: define, plan, build, verify, review, and ship. Success is measured by how well a team navigates the tension between innovation and automation. If you cannot articulate trade-offs between hardware limits and user experience, your role becomes vulnerable to automation because you are only performing tasks that AI can already execute faster than you. The value of human creativity remains high only when it focuses on designing complex systems alongside this new automated capability rather than competing with it on syntax generation. To make the jump from tutorial hell to senior engineering judgment, you must stop optimizing for code volume and start optimizing for system reliability. This means spending more time understanding how your software interacts with physical hardware constraints like GPU memory capacity or network latency before writing a single line of logic. It requires accepting that the hidden skill seniors possess is not magic. It is a disciplined focus on risk anticipation and failure mode analysis. When you shift your perspective to ask what happens under collective pressure rather than how to write a function, you align yourself with the very engineers who are defining the future of AI deployment. The gap between junior and senior engineering is closing in terms of syntax, but widening in terms of system design authority. As generative tools handle more of the repetitive coding tasks, the engineer's role becomes strictly about navigating constraints that machines cannot yet resolve autonomously. This includes understanding how data flows through complex pipelines under load and anticipating where bottlenecks will form before they cause outages. By adopting this mindset, you move from being a coder who follows tutorials to an architect who designs resilient systems capable of withstanding the unpredictability of real-world scale. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.